All right, let's start. Melexis, with the title Melexis Traxxas Magnetic Position Sensors Redefined. It's a sales guy, you can tell that wrote this title. No hate. So, Melexis, what is Melexis? I don't know if everybody knows, but this is a bit of the history, let's say. 2004, we get some IP, magnetic sensors IP. 2005, we start releasing our first sensor. Afterwards, 2010, we start with the Traxxas family, where basically we have all of the different measurements methods, so linear, rotary, and joystick applications. 2012, we keep reinventing. So we go with a PCB-less design, easy for customers that want to integrate this into a system where you would have a long cable and you want something, let's say, connected to this long cable, but you don't want to build a PCB. Then we start talking about ASIL levels right here as well, with some CENT buses and so on. So we keep pushing the boundaries. 2018, we released our high-end product line, which was a 37X series, which, again, we were the new guy on the market that did this. Right now, we are looking right here at stray field immune sensors, and this is where the talk is also going to talk about, where we again redefine the market, where we go into a stray field robust sensing mode. And then, of course, now we're also working right here on a special little project, which is the inductive sensors. And you see right here, Melexis is also no longer a small company. Thanks to everybody here, because you is what makes Melexis great as well. Now, in terms of the talk right here, there's three things I want you to remember. One of the things is who to contact. Who is there to support you in helping your project grow? Second thing is, I want you to have a broad idea of what Melexis does and what the sensors are that are available to you. And the third point is applications. I want to whet your appetite. I want to get you going. I want to start seeing you search for applications that might be in your company or which you might be able to integrate Melexis sensors into. First up, who to contact. Look at this beautiful face. So I'm the field application engineer for magnetic sensors within Melexis for Europe. So this means if you have a question related to these magnetic sensors, I'm the person that you can contact. If you know Melexis, then you know the name Brenda as well. Here's to put a face to the name as well, because it's always nice to see the face who is behind. Now this guy here, who is this guy? He's Magnetic Dave. I'm Magnetic Dave. A good way for you to recognize, let's say, who you could contact in terms of magnetic sensors and magnetic applications. I'm here together with Dacom. There's a few here in the crowd here as well. Now, Dacom is one of our distributors that we have, and we use Dacom, let's say, as the technical guide as well towards customers and the technical guide towards producing or being at production value in total. So Dacom released or got formed, let's say, about the same time like Melexis got formed. So they have two locations right here. So you see right here, they're located in Düsseldorf, and they also have an office in Austria. So their focus is, together with Melexis as well, mainly industrial and automotive applications. Again, to put a face to the name, we're here as well on a booth, so you can visit us as well if you want. But here's the team from last year. So we got Tristan. We got, of course, here Magnetic Dave sticking out of everybody else. I'm a big guy. So we got Carl here as well, who is part of the Austria team at the moment. Then we got Jan, who is like a technical guy, can support you with a lot of technical questions as well. And then, of course, we have Martin here as well. So this is a bit the team, let's say, from Dacom that can support you. Now, okay, It's all good. But okay, position sensors, where can I use this? Think about anything that moves. You need a position sensor. You need to detect a rotation of a valve. You need to detect a rotation of a pedal, a human machine interface, knobs, buttons. You need to detect a rotary action of a robot, for example, the legs or the arms on the rotor on a robot. The possibilities are almost endless. But of course, the technologies are also quite endless. Now, in terms of technologies, magnetic positions, it's of course, I wear the badge of Melexis. This means I'm going to, of course, say that these sensors are the best. But magnetic sensors are the best. Why? You can fully enclose the system into a box without having any outside interference onto this. So you can fully enclose this in plastic. The magnet goes on top. It's fully contactless sensing. Together with that, with the technology that we'll show with Melexis, you also have no issue with straight or air gap variations, for example. So the magnetic strength of the air of the magnet is not really an issue for us. And of course, I'll also explain why, but temperature, we're also stable. More to come. Now, okay, how do we do this? Hall effect. Everybody knows Hall effect from school, or maybe you've done some in your business as well. It's all good, but there's one big flaw in Hall effect. The one big flaw in Hall effect is that you can only measure perpendicular to the sensor surface itself. So this means you need to put the sensor in different positions or funky positions. Of course, there's Melexis to the rescue. What we did here is we put this IMC on top of the silicon. So we have the silicon with the Hall plates inside. We put this IMC, which is called integrated magnetic concentrator, on top of the silicon. And basically, we're bending the field lines. So now not only can we measure in Z direction, which is like this onto the silicon, but we can also measure in X and in Y direction. This is where the triaxis name was born from. Okay, how does this work in application? Basically like this. You have the sensor, you have the magnet on top, quite small package. You have the rotation, which generates a sine and a cosine wave. You put this in a formula, so you get the arctangents of this, and you get basically a vector instead of a field strength that you typically would have with a linear Hall effect sensor. Again, this is good for air gap variations because both vectors will change the same if you change your air gap. This means you will have no effect of air gap variations, no temperature variations, and of course, because it's fully enclosed, it's fully contactless and dirt and liquid free. Additional to this, which is a bonus, is you can also have a push button functionality where you change the Z factor. This is, let's say, this air gap that you're going to change. You could use this as a push button application. So basically what you have here is a full human machine interface with a button, all with a sensor and a magnet. Okay, so what do we sell? What does Melexis want to offer you? This is a bit the product line that we have available, starting from value optimized sensing all the way to the performance sensing, the Ferrari of sensors. And then right here in the middle, you have the mainstream sensing, which has all of the features of or most of the features of the performance sensing, but for a more reasonable cost. And here you see as well the goal of this talk, the 42x series that we're building. Okay, you have an application. You typically use any other method of measuring this rotation. How do you go about and import this into your application? So it all starts with having a few steps in mind. What is your application? What is your output? What do you want to do with this output? How fast does it need to be? And so on. All of this information can be found on some of the selection guides on our website. Very useful tools for you to select which specific sensor you need. Of course, one of the 3 points was who to contact. If you don't find it on the documentation, contact us, of course. If you talk about value optimized sensing, we have a nice portfolio already. This portfolio is more based towards the industries or industrial markets or markets, for example, in home automation or automation markets. We started with the 393 variant. Next to that, we went a little bit more low cost. So this one right here is a 1.8 volt sensor, SPI based, or sorry, I2C based right here. So this one is really targeted to really low cost markets like home automation, for example. Because Melexis is automotive as well, we have an automotive variant, dual die sensors for full redundancy on board as well. And then our latest baby in this family, let's say, is the 397. Really good for industrial markets. We talk about 200 milliteslas maximum saturation point. We talk about higher temperature ratings up to 108 degrees Celsius in operation, and a full voltage range spectrum as well. And of course, like the talk is going about how Melexis is always breaking the boundary, we're again making some new groundbreaking sensors, but more of that to come in the coming months. Okay, we talked about human-machine interfaces. Most of those are next to the human side, but of course you have the motor side as well. Typically, Melexis sensors, because we're in automotive, we need to go analog, digital, digital, analog. They're quite slow, right? So these sensors right here, when we talk about resolvers, we talk about really fast-acting sensors, which are on the side of the motor. So we have a few of them out, which is a 380, 381. The 381, the latest one, is really, again, focused towards automotive with ASIL levels in there as well. Again, sine, cosine, because this is what this market runs on. And again, we're breaking boundaries. We're working on something new, SPI-based as well. Now, the Ferrari of sensors. Did you know that in your car that you're driving right now, there's probably 20 Melexis sensors on board? Gas pedal, brake pedal, steering wheel, valves inside of the engine compartment. Here you can see a few: power steering, integrated braking systems, transmissions, both on the transmission side, so the motor side, and the human machine side as well. Here, the pedals that I talked about, and chassis height sensors. So we have quite a broad spectrum here of sensors. Basically, if you have a certain output that you want, and you have a certain rotary or linear movement that you want to measure, we have a sensor for it. Now, mainstream sensing. So we had a portfolio already within Melexis, which was pretty good. But because we invented or reinvented the market with this performance sensing, we felt that there was a need for more, for better. Because these sensors, most of these sensors were developed also pre-ASIL, so pre-functional safety, the standard that's out there. So we had this clausule as well saying, you know, Melexis has ASIL sensors, but they were equal to ASIL sensors because we developed them before ASIL was a standard. So all of this came into this family that we started to reinvent. Basically, all of this portfolio here, but better, faster, and higher ASIL levels. Okay, that's good, David, but I see here electronic throttle body, exhaust gas recuperation, again, transmission, wastegate, door actuator. Why are you inventing this family right here? Basically, cost again, cost versus features. Where we were here with the old mid-range family, here with the Ferrari of sensors, on the price side as well, but on the performance side as well. So we had to have this family in here, which is now both of best worlds, lower cost than the typical mainstream sensors that we already had, but then also all of the features or some of the features that we had here in the high-end sensors. Together with that comes, as we already discussed, we had this package, which was a package that had no need for a PCB. This package was good. Some of you might remember this package, which we had this dual package sensor with some leads in between. It worked. There were some issues, but with the new family, we reinvented this package as well. We went into a singular package instead of having the two packages. And here you can see the euro cent to compare, let's say, what the size might be of this particular sensor. Again, automotive based, so we're making a single die sensor, but also dual die sensors right here. And the package itself has many benefits versus the other package. First of all, we no longer have internal leads in the middle, which is a cause of shorts and bending stress for customers because they want to have the sensor in a really small package. The ears stay, which is really good. The leads we've thickened, so now this means electro welding towards this sensor is much easier than the previous generation. Yeah, we made the package, let's say, better to work with as well, because if you heat stake right here, you need to have that grip, or you need to have that indent to be able to heat stake this better to the package. You remember I talked about the slide, which was for the sales guy, the very first slide, which was the title of the sales guy. This is an engineer slide. If you talk about the sales guy to this slide, he'll say there's too much text. As an engineer, we say there's nothing as too much text on a slide. So what we see right here is basically the old generation of our mainstream that we had versus the new generation right here. The main differentiator between this is, of course, the ASIL qualification. We went to ASIL B with these sensors. ASIL standard is already quite acknowledged, let's say, in the market. So this is good to have on these particular sensors right here. The second one is, of course, the PCB-less packages, which are really good. We have dual die and single die, like we explained just now. For this one, we do not have. We'll come back to that later. Of course, absolute maximum ratings is one of the key things, which is also better on this family right here. If we talk about automotive, we always talk about getting past the new boundary, let's say. So these voltages right here, we upped so they are more robust overall. Talking about robustness, we talk about higher temperature ratings as well, where typically we're talking about 150 degrees C operating temperature. We're now talking about 160 degrees C, down to minus 40 degrees C. Overall, what else do we have? We have some additional points, calibration points inside of the sensor that you can use as a customer to get rid of any type of non-linearity that you might have, where we typically had a reasonable amount of points that you could put into the sensor, but now we have some more available for you. And a key factor as well in today's market is stray field immunity. It's a buzzword, everybody's using it. Of course, Melexis is also using it. Now, with these families right here, we did not have any stray field immunity. The market was not ready for it. With our generation 3 sensors, so the high-end sensors that we showed on the graph right there, they had stray field immunity. We were using, I must say, the best technology that there was. But for customers, sometimes, if you remember, we talked about 4-pole magnets. We talked about additional things that you needed to worry about. So what we did here with this technology, we went into, again, a stray field immunity type of sensor. But instead of having this 4-pole magnet, which I must still say is the best that is out there for signal to noise, stray field robustness, and so on. But now we also have the 2-pole magnets, good for any applications where you still want to do a 360 degrees rotation in whatever application that you might need. This one right here is going to be for linear movements. So we have 2 discs next to each other, which the linear movement is the only way that you have stray field robustness. So this means this linear movement is the only measurement that you want to do. So any other field that might come in is going to be rejected. So that's the benefit from Melexis. The stray field is typically rejected on a physics level, and we don't do any software magic related to this stray field robustness. There's some other stuff as well, for example, signal to noise, which is better. So what we do here is basically we're bringing the minimum of this 20 millitesla that we had in the future down to a 10 milliteslas overall minimum field that you need. Yeah. So in relation to tools, so I talked about the three things that I wanted you to remember: who to contact, rough idea what we make, also the applications. But a third thing, or a fourth thing, which is also very important, is where can I find the documentation? Documentation in Melexis is very strong. And we really stand on this fact that we want to make good documentation to make sure that you know how to work with Melexis sensors. So this means on the websites, there's oodles of information. There's a lot of information available on the sensors itself, application notes, and so on, data sheets. But also test equipment. How do you start and program these sensors? So for the ones that might know, the ones that might not know, Melexis has this PTC04 programming through connector, which is really useful for any type of module design that you will have. You fully build your module. You have 3 pins coming out of the module: supply, ground, and output. And with those 3 pins, you can basically program your system. So this means any type of non-linearity that you have on the system, you can program just through the 3 pins of the connector. And of course, we're continuing the story here with 421 and 422. And also EVBs are available as well if you might want to start working on making an application like this, but you don't know yet how to make the PCB, or you don't have a PCB design ready. So be sure to ask DACOM as well if you want any type of PTC related items or any type of EVBs. They're already there to help. And overall, the third thing of my to-dos, applications. I want to get you fired up. I want to get you looking at these sensors and saying, I can use those sensors as well. Any of these applications right here has something that moves and that you want to measure. Of course, I don't have the car on here. We had already many cars, motorbikes as well, because you have rain environment, dirt environment. The triggers on the motorbike, for example, can be done with a hard wire. Typically now, motorbikes are done electric as well. So any type of, for example, throttle engagement can also be done electrically with a sensor and a magnet inside. We talk about joystick applications, both for gaming or both for industrial applications, where you have the sensor on the bottom and you have the joystick where you can do with one sensor the full rotation of this joystick application. We talk about industrial robots in industries, which have these shoulder points, if I can say it like that. All of them need a magnetic sensor to define the position of this point, so you can know where this motor is positioned at any given time. Human-machine interfaces on any type of white goods, or even the motor system inside. Human-machine interfaces, because if you're doing laundry, your hands are wet. You don't want this seeping into the electronics. Typically, you do this with a gasket, which is in between, and then the interface itself, which is put on that gasket. Here you can fully enclose it into plastic and have just the magnet on the outside. We talk about open and close detection for doors. Any type of application where there's a door and you want to measure the close detection, there's a magnet behind. Even with your laptop, if you have this electronic or this magnetic paper, you can search for this magnet inside. Flow meters and any type of liquid solution where you have an impeller which has a magnet inside, and then a PCB board on the outside, which is going to detect this impeller movement through magnetic sensor. Any type of gimballing video system, or even these motors for speed detection, for example. Again, here, a really good market, open-close detection, all of these drawers on the printer. I know everybody hates printers when they don't work, but if they have these sensors inside, they will work. So, any type of motor commutation system, which has a drill, or even the trigger inside, which also has this magnetic sensor. like I said, any of these applications on the screen right now can use a Melexis sensor. And I hope you still remember the 3 points. Applications, whet your appetite, ready to go out there. The second one, have a rough idea what Melexis does. I hope this is the case by now. And of course, the very first point, which was on the very first page of the slides, who to contact. Call for Magnetic Dave. And that's it. I hope you enjoyed. Any questions? Or this means I explained it very well, or this means that nobody is daring to ask any questions. That's also a possibility. No questions. Wow, I explained it very well. Very good. Thank you for joining, and see you at the booth. Dacom West, this way you will find us. Have a good day.